Good morning, students. Let us meet once again. We are taking off from where we stopped on Friday. On Friday, I uploaded 2 videos on recurring decimals and factoring polynomials. Today, we are going to continue with factoring polynomials or factorization of polynomials or of binomial expressions or trinomial expressions and expressions that have got more than 3 terms. These are the ones that we refer to as polynomials, which we discussed past Friday. But before I continue, I want to correct something that needs to be corrected. Though I did correct that through the WhatsApp, let me correct it. Remember, we had a problem like this one on recurring. This is a review. Recurring decimals. This is not the objective for today. It's just to review and correct something or put emphasis on something that I did indicate through WhatsApp that it needed to be corrected. So we had a problem more like 1.6 and there's a dot, and we had to convert it to a fraction. So this is the recurring decimal, and we had to convert it to the fraction. And after converting it to the fraction, we ended up with something like 15 over 90, and we simplified this to 3 over 18, and we stopped here. This would make you lose some marks because this is not in its simplest form. It is not in its simplest form. So how do we simplify this further? We know 3 is the greatest common factor of 3 and 18. So you divide by 3, divide by 3, and you end up with 1 over 6. So this is the simplest form of this recurring decimal converted into a fraction. Now today we are going to move on with factoring polynomials. Factoring polynomials. So we are moving on with factoring of polynomials. And I have the notes that I gave to you on Sunday. And we indicated that there are several methods that we are going to apply here. And one of the method is method of common factors. So this is one of the methods that we employ to factorize a polynomial. And I gave examples like A times B plus C equals AB plus AC. This one we know from the property of distributive, or the distributive property. So when you have a number that is outside, or you have a scalar quantity, or you have a quantity outside the brackets, and there are terms, there's an expression inside. To remove the brackets, you multiply this A by this one, multiply this A by the second term. Don't forget the signs that are in between. So this is A times B, which is AB, A times C, which is AC. Now, to factorize using the common factors, you reverse this. You now move from this one going this way, which means AB plus AC equals, you look at the 2 terms. There is this term, there is this term. Which of these quantities, of these variables is common? We've got a variable A here, a variable A here. It is common to both the 2 terms. So you pull it out. When you pull it out, you must show that by enclosing a bracket. You have an opening bracket, you pull it out. When you pull it out, the concept of division comes in. You then say A into AB. So this A and this A cancels out. You remain with B. And the sign that is here, you place it here. A into AC. The A cancels this A, you remain with C. So this is what we refer to as factorizing using the method of common factors. Now let's get to an example now from the notes. Example. So we are going to use example, say, example number C, which is 3x to the power of 6 minus 9x squared plus 3x. So the question is factorize fully. Factorize fully. So this question here, you look at the three terms. There are three terms, 1, 2, 3. Remember, in an expression, terms are separated by either the minus or the plus sign. Everything is clearly explained in the notes. I'm not going to waste so much of your time explaining that because it's there in the notes. So an expression is made up of terms separated by subtraction and addition sign. Those are distinct terms. So there is 1, 2, 3 terms. So you now look at the 3 terms and identify those terms of variables or those numerals that are common. So you start with numbers. There's a 3 here, there's a 9 here, there's a 3 here. You must look for the biggest numeral or the biggest number that can go into 3 and also into 9 and also into 3 without leaving a remainder. And that number is what we refer to as the greatest common factor. So the factors of 3 here are 1 and 3. Factors of 9 are 1, 3, and 9. So the biggest number that is appearing in both factors of 9 and 3 is 3. So we have 3 as one of the quantities that we must factor out. We are done with the numerals. Now we go to the variables. The variables, we have got x here, which is x to the power 1. We have got x here, which is x to the power 2. We have got x here, which is x to the power 6. So last time we said the highest or the greatest common factor among the variables, it will be the variable with the smallest degree. These powers are the ones that we refer to as degrees. This is degree 6, degree 2, degree 1. So if you have a variable, same variable in different terms, the highest or the greatest common factor is the variable with the smallest degree. In this case, x to the power 1, it will be our common factor, the greatest common factor. So we will take it and combine it with 3x, and then you make an opening bracket, and then you say 3x into 3x to the power 6. 3x into 3x to the power 6 is the same as 3x to the power 6 divided by 3x. That is the interpretation of this. This 3 cancels with this 3. Now, x to the power 6 divided by x to the power 1 is the same as x to the power 6 divided by x to the power 1. We are using the symbol for division. This is one way of presenting division. This is another way. And from here, we use the method of indices. The law of indices for division says when you divide numbers with the same base raised to a power, you take the common base and subtract the powers. When you are dividing quantities with the same base, this one, the base is x, the base is x, the power is 6, the power is 1. When you divide two quantities with the same base, take the common base, subtract the power. So this will be x to the power of 5. So we have here x to the power of 5. We don't normally write 1x to the power of 5 because it will not be simplified in its simplest form. Now we go to the second term, 3x into this term together with its sign. This is positive, this is negative. So the sign here will be negative because when you divide a negative number by a positive number, you get a negative answer or negative quotient. So 3 into 9, it is 3. X into x squared is x to the power 1. X to the power 2 divided by x to the power 1. We apply the same concept that we applied here. We apply the same concept that we applied here, which will mean x, which will be x squared divided by x to the power 1, which is the same as x to the power 2 minus 1, which is x to the power 1. But we don't normally leave our answer as to the power 1 because it will not be in its simplest form. In its simplest form, it is just an x. So this is x, which we understand to be x to the power 1. So this one here, it will be x. And then we have a plus. You drop down the plus, 3x into 3x. When you divide quantities that are the same in terms of value, the answer is always 1. So this will be our factorized polynomial. So inside the brackets, there is no common factor here. When you look at this one, there is an x to the power 5 here. Here there is an x. Here there is no x. So x is not common. So when you look at this one, there is a 3 here. There is no 3 here. There is no 3 here. So 3 cannot be common. 1 is the only one that can be common, but it is pointless for us to factorize using a 1 because it will not change anything. So this will be our final answer after factorizing fully. Now let me use this part of the board. Take another example from the notes and we do it together. Let me take a different one, which is part F, and this is x times a minus 2b plus y times a minus 2b. Remember, we are factorizing using the method of common factors. Common factors, we look for the greatest factor that is common to both the terms. Remember, we said the terms are separated by an addition sign. Let me make this bigger so that you can see that there is this term, there's also this term. So this plus sign is the one that separates the two terms. Now looking at these terms, if we look here, let's start with this one that is outside the bracket, x. Okay, there's an x here, but let's look here. Do we have an x? No, we don't have an x. So x cannot be common. Let's try y. Yes, there's a y here, but do we have a y here? No, so y cannot be common. Let's look at the one that is enclosed in bracket. It's a minus 2b. Do we have a minus 2b after the plus sign in the second term? Yes, a minus 2b. So a minus 2b is common. So we'll pull it out. So it will be a minus 2b. We have pulled it out. The moment you pull it out, you must open brackets here. Then you say a minus 2b into this term. A minus 2b will cancel out with this one. You remain with x. And this plus here, you drop it down to plus here. And then you say a minus 2b into this. A minus 2b cancels this. Remain with y. So this is your fully factorized polynomial. So that is how you factorize using the method of greatest common factor. So that is that. I believe it is simple and straightforward. I've got extra problems for you. Look at those problems, do them. If you have any challenges, the WhatsApp group is open. The Moodle is also open. Just write a question, ask a question. You can send me a voice note, then I'll respond accordingly. I'll also prepare a video, shoot a video to address all the queries, all the questions, all the misconceptions that we might be having. Thank you for now. And I'm going to give you a short break to try and look at these other problems that we have in our notes. Work them out. If you have questions, you should ask. And after these, we are going to continue with another method of factorizing, which is the method of quadratic factorization. Thank you so much, my students.